Hi everyone, and welcome to our webinar today, Charging Ahead Innovations in Maritime Electrification. I'm Marcel, Marketing and Communication Manager at Blueday, and together with me I have Hans-Peter, our Chief Commercial Officer. Hi, both of us are looking forward to you today, exploring the complexities of maritime electrification and the innovative technologies that are shaping the future of this industry. Today, we will dive into the capabilities of Blue Eco Charger technology. We also explore the challenges and solutions in implementing high-capacity charging infrastructure and discuss future trends in electric vessel design. We will also share some success stories in the end, showcasing real-world applications of our technology. And we really encourage you to participate actively and share your thoughts during the Q&A session at the end. So without further ado, let's begin with an introduction of the Blueday technology. Blueday Technology has undergone a significant transformation since its founding in 2013. Initially focused on the oil and gas markets, the company pivoted towards electrification between 2018 and 2020. This strategic shift emphasizes the importance of energy optimization and smart power achieving a lower carbon footprint. And this is not just a transition, it's not just a business strategy, it's a commitment to a greener future. Our Blue Eco solutions are designed to drive sustainability in ports worldwide. Each solution, including Blue Eco Shore Power, Blue Eco Charger, Blue Eco Power Generation, and Blue Eco Vision, plays a crucial role in optimizing energy distribution and supporting the transition to renewable energy. You can visit our new website to read more about each of these offerings and also find related customer stories for reference. Talking about sustainability, it is really at the core of Blueday Technology's mission. The maritime industry has a crucial role in reducing its carbon footprint, and our Blue Eco technology is leading this charge. By optimizing energy demand, distribution, and supply, we facilitate a seamless transition to renewable energy sources. And this commitment is really rooted in years of R&D, ensuring that our solutions not only meet current needs, but also anticipate future challenges in energy management and environmental responsibility. If we look into some data you see here on global trends and market growth, we see the rapid growth of the megawatt charging system market, expected to grow from $909 million in 2025 to over $5 billion by 2034. This surge is driven by government emission targets, rising EV adoption, and the push to electrify heavy-duty transport like cargo, public transit, and freight. As fleets transition away from fossil fuels, high-power solutions like megawatt charging system become really critical. Electrification is no longer optional. It's a key strategy for meeting sustainability goals and building future-ready infrastructure. Demand for fast, high-capacity charging grows, the question becomes, how do we deliver it efficiently, reliably, and sustainably? That's where solutions like Blue Eco Charger comes in. To tell us more, please welcome Hans-Peter.
Yes, hello everyone. My name is Hans-Peter Heggeberg. I'm pleased to join you here at this live webinar from our headquarters in Stavanger. So with 30 years of experience in the offshore and marine industry, it's my pleasure to give a touch point in marine charging system. I have a background from power system design and been in Blueday Technology since day one and one of the company founders. Development of new technology in a market without standardization and regulation is not straightforward. With only tailor-made and prototyped installation, the customer investment cost will only increase and never have a sustainable development. The marine industry is transforming towards e-mobility as part of its commitment to sustainability and reduction in carbon emission. Shipping currently accounts globally for around 2.9% of the CO2 emission. And therefore, ports and terminals along the coast and inland waterways are essential in reducing the maritime industry's carbon footprint. Without intervention, these emissions could increase significantly, undermining efforts to combat the climate change. Ships have varying electrical systems and configuration, but that doesn't mean that we must implement one charging system for each ship type. Standardization efforts and the development of adaptable technology are essential to overcome the compatibility issues. It is important to address port authorities and administration and other players in the context of an increasing maritime charging development and deployment, both in the potential of role of developers, operators, and promoters of marine charging projects. It is inevitable to implement energy utilization, securing a stable energy provision and grid stability, proportionally with the development phase for the future of electrical mobility and transportation. So let's have a look into the charging system that we provide. We have two product lines. One is the Blueday combined charging system, so-called CCS, and well known as the CCS2 for electrical cars. We provide a max rating of 500 kilowatt at 1000 voltage DC for each connection points that we have. And the second one is the Blueday Megawatt Charging System, MCS, with a max rating of 1.5 megawatt at 1000 voltage DC for each connection points. For marine charging, the charging points are delivered as a standard with two MCS connection or two CCS connection plugs to the ship. One CCS2 connection plug for electrical vehicle like trucks or trailers can be mounted as an option. As standard, the charging system is delivered with plug and charge for easy connection and startup of the charging session. User login, RFID or other solutions can be delivered as an option. The charging pod comes with two versions, one for city environment and one for industrials for use at terminals. The base frame can vary in height due to local flooding requirements. At the backside, a large screen for route tables or other irrelevant information can be installed as an option. Handling of the plug connection, manual or semi-automated. When not in use, the connection plugs are safely locked to avoid vandalism. The charging pod requires auxiliary power supply for the cooling and control system. Incoming main power cables are connected in the base frame and can be installed before the top section is fitted. Today, we have well implemented international standards for connecting various types of ships to the onshore power grid when it comes to AC power. This includes low voltage up to 690 voltage and high voltage either on 6.6 or 11 kV, in which we will explore in a later webinar. The upcoming IEC 80005 Utility Connection in Port Part 4, called DC Shore Connection System General Requirements, describe low voltage DC shore connection systems up to and including 1500 voltage DC. It applies on board the ship and onshore to supply the ship with electrical power from shore. This standard is applicable to the design, installation, and testing of shore connection system, and it will address topics like DC shore distribution system, shore to ship connection and interface equipment, the transformers being used, power electronics like rectifiers and DC-DC converters, ship distribution system, control, monitoring, interlocking, and power management system. The standard does not apply to the electrical power system supply during docking periods, for example, dry docking or other out-of-service maintenance and repair. It does neither apply to power supply below 500 kilowatt or pleasure crafts up to and including 24 meters of length. As you see here, there is two connection points or plugs. We have the CCS2, as you are well familiar, being used with electrical cars, and the new one for the megawatt charging system. The new megawatt charging system plug will have a capacity in current of 1500 amps. Normally, we provide now up to 1000 voltage DC from the system, so the maximum power rating will be 1.4 megawatt. The cable is small. It's around 2 kilo for each meter for the MCS and 1.45 kilo on the CCS2. And the plug is 3 kilo on the MCS and 1 kilo on the CCS2. All connection points are fully electrical galvanic isolated. This to avoid galvanic current that can cause corrosion in the vessel hull, propeller, shaft, and so on. The ratings are with continuous charging in all conditions up to 50 degrees ambient temperature. The plugs have best-in-class performance thanks to direct liquid cooling technology and have maintenance-free system using a safe and biodegradable directly coolant. The system include also a tension shutdown solution for safety due to vessel is not moored at the quay. The utility and rectifier station can either be delivered on a skid frame for installing in buildings or as a container solution in various sizes. The utility and rectifier station is developed for connecting of various ships and ship configuration when it comes to battery technology on board. This means that the system handles various battery technology and voltage level in which is provided by the shipbuilder. The system comes with an active front-end technology followed by a DC-DC converter with proper software able to optimize the charging session. The grid connection point and voltage level can be up to 22 kilowatt voltage level and 50 hertz. The system can handle energy flow in both directions, in addition to integrate with energy storage for boost charging when grid supply is not sufficient. As an option, renewable energy sources like solar or windmills can be connected as a complement to the grid supply. Okay, so On the utility station and the charging pod, they have their own control and monitoring system, isolated from each other. To put this in together, we have a top management system called Blueday, in which is a cloud-based asset management system for shore power and charging infrastructure that will provide an overall control and monitoring of your installed base. The Blueday is designed for the future with focus on digitalization and data collection. It allows real-time reports, analysis, and condition-based monitoring. With a large amount of data, Blueday supports the operator by taking the right decision at the right time with tools like implemented corrective maintenance program. Blueday focus on the operator's control philosophy and simplicity for the users. It includes an advanced alarm management system made according to relevant industry standards that helps the operator in taking correctively actions and minimizing potential risks. The Blueday simplifies the process and present data needed related to technical performance, energy flow, and emission, either through a client-specific report as a monthly service or through data transfer to client system in Microsoft Azure or other platform used. The data storage is available as a solution in the cloud, giving the user a unique possibility for accessing powerful data. It is beneficial to have a system that provides correct parameters and reports to ease the reporting further to government institution, various internal company reporting, or financial cost and income control. So what kind of impact does the Blueday charging system have on marine electrification? It facilitates the transition to zero emission operation in ports worldwide, aligning with global sustainability objectives. It reduces the vessel's downtime through rapid charging, leading to increased operational efficiency in maritime logistics. It provides scalable and adaptable charging solution, aiding in the development of sustainable port infrastructure. It also sets a precedent for innovative charging technology, encouraging the widespread adoption in the maritime industry. Lost productivity caused by poor performance or unplanned failure of the power plant or the automation system can significantly reduce the revenue and profitability. To reach the operational and business goal, our customer needs to keep the critical asset running at peak efficiency. Nevertheless, not all companies have the resources to develop and sustain a development program that will optimize their operation environment. We cannot avoid the fact an installation of the onshore infrastructure demands a considerable upfront investment and sufficient grid allocation. Early involvement and collaboration with us at Blueday Technology can ease the implementation required now and down the road, considering operational needs, financial structure, and further expansion according to customer business plan for their ports and terminals. It is therefore extremely important that the port set the terms. The designer of the vessel and the shipbuilder will always be able to adapt. Do you have the stable grid access with sufficient capacity? Is there space for installing charging stations or power units? Are shore power connection already in place or planned? What type of vessel use the port? Is it like ferries, workboat, leisure? What it is? How frequently does vessel dock and for how long? Are any vessel already electric or hybrid? What charging power levels are required? Is it like 500 kilowatt or is it like a megawatt class? Do you need fast charging with a turnaround under 1 hour? Will multiple vessels charge simultaneously? Are there local or national emission reduction targets? Are you eligible for green infrastructure funding or grants? Do you aim to integrate renewable energy like solar or wind? What is your initial budget for electrification? Do you need a modular system that can scale over time? Are your operational costs, like maintenance and energy, sustainable? Have you considered with the supplier? Do you need automation or manual plug-in system? Have redundancy been considered? Are ports operator, vessel owner, and local authorities aligned here? Have you consulted with energy providers and grid operators? Or is there a long-term electrification roadmap? These are the things that you have to take into consideration and some of the things that we can help you with. So what trends are there in electrical design for vessels? We see that the batteries are improving, but alternative battery chemistry and hydrogen fuel cells are gaining traction for longer voyages. Shipbuilders are exploring composite materials and aluminum alloys to reduce vessel weight and improve energy efficiency. AI-powered navigation and energy management system will optimize routes and battery usage, reducing operational costs. Combining electrical propulsion with renewable energy sources like solar and windmill will enhance sustainability. Ports will and is required to develop fast charging station to minimize downtime and support larger electrical vessels. Battery voltage are increasing from approximately 400 voltage up to 1000 voltage DC. When it comes to wireless and inductive charging, this is a topic I've been asked several times. Some vessels may adopt wireless charging technology, reducing reliance on physical connectors. Studies have highlighted the advantage of wireless induction charging for maritime vessels, emphasizing its ability to eliminate physical connectors, reduce maintenance, and improve reliability in extreme condition. But still, wired connections typically have lower energy loss compared to inductive charging, followed by a much higher investment cost. Ships will connect to smart grid in the future, combining shore power and charging, allowing optimized energy distribution, reducing strain on local power networks. A grid connecting plan will be implemented for optimized energy flow and availability. The technology is mature, but the market does not yet follow. So the industry standard for charging and ports connector will ensure compatibility across different regions and reduce investment cost. This is a picture from port of Stavanger. Blueday Technology have done installation of 3 charging pods and 1 utility and rectifier station in a building. Each charging pod contains 2 MCS plugs and 2 CCS2 plugs for ship connection. 2 of the charging pods are manually handled, and 1 of the charging pod is semi-automated. Each MCS ship connection can provide 1.25 megawatt at 1000 voltage DC, and each CCS2 ship connection can provide 500 kilowatt at 1000 voltage DC. The charging session is controlled by plug and charge solution, and there is reserved space and plan for expanding with 3 more charging pods and 1 utility and rectifier station to scale the charging solution at the port. The system will be used for commercial passenger vessels in daily traffic, giving a huge number of daily connection. Yes.
Yeah, so that was a lot of information, and we've covered a lot today. But I guess it's time for Q&A. We will try to cover some of the questions, and the rest we can take offline. So, first question that comes in is, how scalable is your charging infrastructure for future needs, especially with the growing size and number of electric vessels?
Yes, as mentioned in the presentation as well, our solution is scalable, uh, especially taking into consideration the power and utility station. That's the main part here. It's being set up like a modular case. So if you invest in a system like 3 megawatt charging system, it's easy to expand modularly to whatever that is required. And that will also include the possibility to implement energy storage systems so that you can use the boost charging if there is not sufficient grid supply.
Thanks. If this answer your question, good. If not, please write the next question to clarify or get more details. But we move forward. What are the typical installation and maintenance requirements for a shore-based charger system in a busy port environment?
Wow. Yeah, it is like normally we set up, like a service and maintenance plan with the customer, so that we can ensure the downtime for the system as less as possible, securing redundancy so the operation will continue. Normally we have our procedure that we do maintenance and service once a year of the system itself. But it's important that the customer at all time have recommended spare parts, either through us or they have them by themselves at their own stock. So it's easier to do any critical services.
Mhm. Yeah, thanks. Next question. How do you ensure safe connection and disconnection in harsh maritime environments, especially during high tide storms or rough docking scenarios?
Yeah, that depends on what type of connection you have, but normally it's manual handled. So it's like you connect it by manual operation into the plug. But normally, like high-speed passenger vessels, they are not moored at the quayside. They are kept there by the thruster system on board, meaning that theoretically the captain can leave the quayside with the plug in the system.
Mhm.
but we have a tension system on the cable, meaning that if there is a stretch on the cable, it will give an alarm, and followed by a shutdown of the system to secure any damages or any other personal damages around the area.
And I guess this would be the last question. How is data from your charging systems used to optimize performance, predict maintenance needs, or integrate with fleet management platforms?
Yes, what we do is that we have an overview of more or less all devices in the charging port and the utility station, and we do measurements and control of them. We catch all the various data into the cloud system, and by historically data, we can go back and forward, or we can use the data as optimizing the system. For instance, using condition-based monitoring, or like other whatever requires for using the data.
Yes, so that was it for the Q&A part. We wanted really to have a dialogue with you. So for all the questions we didn't answer, we come back separately offline. And if you will like to continue the conversation, meet us in person at North Shipping, which is happening in Lillestrøm, nearby Oslo, from 2nd to 6th of June. We do have a stand there, so just come by and say hi and meet our team. And then there is another event happening end of June from 24th to 26th in Amsterdam. It's Electric and Hybrid Marine. It's a great arena for networking, for getting to know new players on the market, and also getting to know us. So come and visit us if you are there, and feel free to drop a line if you are planning to attend, so we can set up a meeting. We also will be announcing a webinar soon, this time focusing on shore power. So remember to follow our LinkedIn page, where you will see all the announcements coming. And there we will also share the recording of today's webinar. And in a comment section to that recording, we can continue the discussion and do the Q&A there. And here you see our team, key people in the organization whom you can reach out, scan the QR code, you will save their contacts, and reach out directly if you have any questions around what we discussed today, or around anything that is related to the industry. So that brings us to the end of the session, and we were really happy with getting all of you joining us. Thank you once again for being with us. Let's keep in touch. Let's meet again in the next webinars to come. Thanks for now, and see you soon. Bye-bye.